So now we're going to look at the final value theorem. Now this is similar to the initial value theorem. Whenever we go through and describe it in words, it might not make a lot of sense, but we'll go through the example here at the bottom and it'll make a bit more sense when we go through the example. So let's look at it in words first. The final value theorem tells us that we can find the value of a function at infinity in the time domain by looking at how the function behaves at 0 in the complex frequency domain. So we'll go ahead and we'll prove that. So let's take a function g of t and we'll find the Laplace transform g of s. So we'll say g of s equals integral from 0 to infinity of g of t e to minus st by dt. So now we'll take the limit as s tends to 0 of this Laplace transform. So that's the limit as s tends to 0 of the integral from 0 to infinity of g of t e to minus st by dt. Now we can see here as s tends towards 0 we get e to the minus, and that will tend towards 0. So e to the minus 0 is n to the power 0 is just a value of 1. So that just gives us the integral from 0 to infinity of g of t by dt. Now we're interested in a function which is not g of t but it's a derivative. So we'll introduce the new function, we'll call it f of t, and we're interested in the derivative of that function. So what you're interested in is the integral from 0 to infinity of f derived of t by dt. So we know that taking the Laplace transform of this function here gives us a value s f of s minus f of 0. But of course we're looking at the limit as s tends towards 0. Okay, so we'll have this function here. So therefore we can look at the left hand side here. On the left hand side here it's the integral of a derivative. So that'll just give us the value of the function f of t. So the limit as t tends to infinity of f of t minus the initial condition f of 0. So that's going to equal the right hand side, which is the limit as s tends to 0 of s times f of s minus f of 0. So the f of 0s cancel out, and finally you're left with the limit as t tends to infinity of f of t is equal to the limit as s tends to 0 of s times f of s. So let's look at an example. Let's say we have the function f of s equals 1 upon s minus a for a less than 0. Then if we were to take the limit as t tends to infinity of f of t, according to our little identity here, that's the same as saying the limit as s tends to 0 of s times the f of s. So s times f of s is going to be s upon s minus a. So we can see this here, that this limit as s tends towards 0 is just going to be a value of 0. So let's see if that's actually what happens in the time domain. So the time domain equivalent of this function here, f of t equals e to minus at u of t. Now remember here we're dealing with values for a less than 0. Okay, so it means then that as t tends off to infinity, we're going to have e to the minus infinity. So e to the minus value of infinity is just going to tend towards 0 as t tends towards infinity. So that does in fact work. So we can see here then that we've found a method of finding the value of a function of time when t tends towards infinity by looking at the value of the function in the complex frequency domain as the value of s tends towards 0. So that's the idea of the final value theorem. So that's all there is for this video. I'll get you on the next video. Goodbye.